Good morning everybody. Today we will discuss about integration using partial fractions method. Integration using partial fractions method. We already discussed the partial fractions in 2a. Now, how can I integrate x minus 1 by x minus 2 into x minus 3 dx? I did not give any formula for this type of terms. X minus 1 by x minus 2 into x minus 3. How can I integrate? So, these if you observe, this can be converted into two partial fractions. Sum of two fractions we already discussed. If we are able to split into two partial fractions, then we can integrate easily, separately. So what I want to say is, find the partial fraction of x minus 1 by x minus 2 into x minus 3. This we know how to find. You can write a by x minus 2 plus b by x minus 2. A by x minus 2 plus b by x minus 3. Now you know how to find a, b values. Shortcut method I told you, eamcet, and IP method I told you. You go for IP method because this is IP. So, if you take LCM is x minus 2 into x minus 3. Here we will get a into x minus 3 plus b into x minus 3. So this side x minus 1 by x minus 2 into x minus 3. These two will get cancelled. Now let x equal to 2. Let x equal to 2, we will get a value. X equal to 2 means 2 minus 1, 1 equal to a into minus 1 implies a equal to 1. Implies a equal to 1. Then let x equal to 3 gives you b value. Let x equal to 3 gives you b value. Substitute x equal to 3 here. 3 minus 1, 2 equal to a into 0 plus b into 3 minus 2, 1. So b is 2, a is 1. So I can write this as a by this plus b by this. A is 1 by x minus 2 and b is 2 by x minus 3. 2 by x minus 3. Like this, you can find the partial fractions. Like this, you can find the partial fractions. Now, I want the integration of this is nothing but integration of this one. So, fx plus dx integrate separately, then gives you simple integration. This 1 by x integration, log mod x. Log mod x minus 2. Log mod x minus 2. Plus, if I write 2 outside, this is x minus 3. Log mod x minus 3. So, this is m log a, log of a power m. I can simplify and you can leave here. 100% you can leave here. If you simplify, this is log of a power m. Again, log a plus log b, log of a by log of a into b means x minus 2 into x minus 3 whole square plus like this. You can use the partial fractions to integrate these type of functions. So whenever you find this type, which you can divide into partial fractions, you can split into partial fractions, then integrate will be very easy for you. It will be very easy for you. Integral of x square by x plus 1 into x plus 2 whole square dx. X square by x plus 1 into x plus 2 whole square dx. Exercise 6e. Exercise 6e. Now, the same you can go for partial fractions. If you observe, this is a linear fraction, but this is a linear with repetition. Linear with repetition means repeated linear fraction. So you should write a by this, b by this, plus c by this whole square. We will already learn how to find the partial fraction. X square by x plus 1 into x plus 2 whole square equal to, you can write a by x plus 1 plus b by x plus 2 plus c by x plus 2 whole square. So find a, b, c. Then you can substitute those values. So if I take LCM, this becomes x plus 1 into x plus 2 whole square. So this becomes a into x plus 2 whole square plus b into x plus 1 into x plus 2 plus c into x plus 1. C into x plus 1. This side x square by blah blah blah. So these two gets cancelled and now this becomes x square equal to a into this, b into this plus c into this. Now making this is 0, let x equal to minus 1. Let x equal to minus 1 gives me a value. Minus 1 whole square 1 equal to a into minus 1 plus 2 whole square becomes a plus 0 plus 0. So implies a equal to 1. A equal to 1. Next, let x equal to minus 2 gives me c value I told. Highest power c value. So x equal to minus 2 if I substitute here. Minus 2 square 4 is equal to, this is 0, this is 0, c value I get. C into minus 2 plus 1 minus 1. So c equal to minus 4. C equal to minus 4. C equal to minus 4. I got a and c. Now if I take such comparing quotient, I will get d value. Comparing quotient of x square. Comparing quotient of x square we already did. Comparing quotient of x square is nothing but 1 is equal to this side a plus b. A plus b. So a value I know already. If I substitute there, I will get b value. So 1 here a value if I substitute 1 minus 1 0. So b is 0. So what I got? A is plus 1, b is 0, and c is minus 4. C is minus 4. This is what I got, a, b, c values. Now integrate separately. So integral of this is nothing but integrate separately means integral of this whole thing equal to integral of this plus integral of this plus integral of this. Is nothing but 1 by x integration log mod x plus 1, and this is 0, no need to write, plus 0 only. Next, minus 4 into integral of 1 by x power square means x power minus 2, it becomes x power minus 2 plus 1 minus 1. So x plus 2 whole power minus 1 by minus 1 plus c. So the final result is log of x plus 1, log of x plus 1 minus into minus plus 4 into 1 by, means 4 by x plus 2 plus 4 by x plus 2 plus c is your final answer. So what I am doing is I am going for partial fractions. A by this plus b by x plus 2 plus c by x plus 2 whole square. Then I am finding a, b, c values, then integrating on both sides. Then integrating on both sides. So this is a simple way of integrating this, because there is no u by v rule in integration. There is no u by v rule in integration. Next, third type. This is linear. This is quadratic which we cannot factorize. Quadratic which cannot be factorized. For this what I told, x plus 3 by x minus 1 into x square plus 1 equal to a by x minus 1 plus, this is a quadratic which cannot factor, it means take the linear factor in the numerator I told. Means bx plus c by x square plus 1 or 1 plus x square. Bx plus c by x square plus 1 or 1 plus x square. So like this, if you find ABC, then we can integrate separately. How to find ABC? So say LCM is x minus 1 into x square plus 1, and here is a into x square plus 1 plus bx plus c into x minus 1, and on this side x plus 3 by x minus 1 into x square plus 1. So these two gets cancelled. Now let x equal to 1. Let x equal to 1. And get a value. If you substitute 1 here, 1 minus 3 minus 2 equal to a into minus 1 square, 1 plus 1, 2 plus 0. 1 minus 1, 0, 0 and everything 0. So a equal to minus 1. A equal to minus 1. Next, coming to b, you can go for comparing quotient, no other way. So go for comparing quotient of x square. Comparing quotient of x square. Here there is no x square, so 0 equal to, here a into x square a plus b into x square quotient means b, a plus b. Now a value minus 1 I got, if I substitute, b automatically plus 1. B is plus 1. Now, how to find c value? Comparing constant I will take. Here constant is minus 3. Minus 3 equal to this side constant A minus C. A minus C. So I know A value again. If I substitute -1 here, -1 here. So minus 3 equal to -1 minus 3. C to this side, minus 3 to that side. 3 minus 2. 3 minus 1 is 2. 3 minus 1 is 2. So C equal to 2. So I got A is -1. A is -1. And B is 1. Means plus 1x. And C is 2. C is plus 2. So now integrate separately. Now integrate separately. How do I integrate separately? Now in ABC we want, so we have substituted values, then integrate it separately. How do I integrate? So integral of this equal to integral of this plus integral of this. This is easily we can find -1 outside. 1 by x integration log mod x. So log mod x minus 1. Here there is a problem again. So you can split it into two parts. X by x square plus 1 plus 2 by x square plus 1 or 1 plus x square. X by x square plus 1 plus 2 by x square plus 1. I am split it into two parts. Why? Because x square derivative is, I know that 2x. X square plus 1 derivative is 2x. So into 2 by 2 if I do, into 2 by 2 if I do, derivative of x square plus 1 is 2x. So I got in the form of f dash x by x. I got in the form of f dash x by x. Now this is 2 if I write outside, 1 by a square plus x square formula I can use for that. Means this is minus log of x minus 1 plus 1 by 2 into f dash x by x log mod f x. So log mod x square plus 1 log mod x square plus 1. Coming to this, integral of dx by 6x square minus 5x plus 1. If you simplify, if you can factorize this, then go for partial fractions. If you cannot factorize, then there is another method called completing squares. First of all, you check whether it can be factorized or not. I think it is factorized. 3 2 is 6. 3 plus 3 plus 2, 5. So minus 3 minus 2 minus 5. So what I want to write is integral of dx by splitting the middle term gives me 6x square 3 minus 2, but minus 3 into minus 2, is it minus 6x? So minus 3x minus 2x minus 5x plus 6x square 100% right plus 1. So if I take 3 common from these two, this becomes x minus 3 and minus 1 common. So you want to get the 6 1 ja plus 6 means minus 3 minus 2, 100% right. So if I take 3 common, 3x common becomes x minus 2, minus 1 common x minus 2. So integral of this is dx by, you will get finally 3x minus 1 into x minus 2, 3x minus 1 into x minus 2. Now we can go for partial fractions of this. If you can factorize, then go for partial fractions. So this is a by 3x minus 1 plus b by x minus 2. A by 3x minus 1 plus b by x minus 2. B by x minus 2. So this side 1 by 3x minus 1 into x minus 2. If you take LCM, so this becomes a into x minus 2 plus b into 3x minus 1. Now 1 is equal to this. Let x equal to 1 by 3. Let x equal to 1 by 3. You will get a value. A into 1 by 3 minus 2. 1 by 3 minus 2. So plus b into 1 by 3 into 3. 1 minus 1 0. So you will get a value as 3 LCM if I take 3 minus 6. 1 minus 6 is minus 5 by 3. So I want to say a equal to minus 3 by 5. A equal to minus 3 by 5. Next, coming to b value. If I substitute x equal to 2, I get simply b. So 1 is equal to, this is 0, 6 minus 1, 5. 5b. So b is equal to 1 by 5. A is equal to minus 3 by 5. So how can I write this is A by A is how much? I got minus 3 by 5 by 1 by 3x minus 1 plus B by B is 1 by 5 by x minus 2 x minus 2. Now integrate this. Now integrate that. Direct integration you can do. So minus 3 by 5 anyhow outside 1 by x integration log mod x. But there is a small problem here. Log mod of 3x minus 1 not x. 1 by x is log mod x. It's not x. It's a linear function. So divide with the divide by 2. So minus 3x divided by 2 is 3. So divide by 3. This 3 gets cancelled. Next plus 1 by 5 into. This is log mod x minus 2. Derivative of x minus 2 is 1 only. No need to do. Here not x. This is 3x. That's why you should divide with 3. So 3 gets cancelled. Plus c. This is the final result. This is the final result. So if we can factorize, then go for partial fraction. That's what I want to say. Sometimes you cannot factorize. In those cases, you should go for completing square method. You need to go for completing square method. That we will discuss now. Now exercise 6D. If you cannot factorize, then you should go for completing square method. It is a quadratic equation ax square plus bx plus c, which you cannot factorize, then go for completing square method. Even it is factorized, you can go for completing square method. But if you go for factorization, it will be easy. Partial fractions is very easy. That's why that we will do. Now here we will go for completing square method, which you cannot factorize at all. So we will try to sum from the exercise 6D, then you can understand. 1 by cos x dx by cos x dx by sin square x plus 4 sin x plus 5. Sin square x plus 4 sin x plus 5. Exercise 6D. First one and third sum. Which now, if I take sin x is t, this is not direct form also. Substitution along with the factorization method. So sin x equal to t. Let sin x equal to t. What is the derivative of sin x with respect to x? What is the derivative of sin x? You know that it is cos x. Cos x dx equal to dt. So instead of cos x, I can cos x dx, I can write dt by sin square x is t square plus 4t plus 5. T square plus 4t plus 5. So now, can I factorize this? I can't. Usually I can't. Even if you can go for completing square. Completing square is sanctioned for anything. Even if it is factorized or not factorized. But partial fractions is better suggestion. Now coming to this, if you do not factorize, if you cannot factorize, go for completing square method, which you learned in our 10th class. So I will tell you simple method. Completing square is nothing but this should be written in the form of a plus b whole square. This is a square plus 2ab plus b square. Means I have in place of 2ab 4t I have. Means in place of 2t I have 4. So b is equal to 3. Always take the quotient of x, make it equal to 2b. Quotient of x, make it equal to 2b. Then you will get b. Square b square is 4. B square is 4. Squaring b gives you b square. Now, adding and subtracting b square. Adding and subtracting b square. Always it will be completing square because dt by t square plus 4t plus b square I told 2 square 4 plus 4 I am doing I should do minus 4. So that value will not change. Plus 5 as this. I am finding 2b as x quotient and I am finding b square. I am adding b square, subtracting b square. So that plus 4 minus 4 doesn't change the given value. So this is a plus b whole square of the a square, t square plus b square 2 square 2ab 2 into t into 2 4t. So this is a plus b whole square always. So for completing square, take b and adding b square, subtracting b square, automatically this is a plus b whole square. This is 5 minus 4 1. So finally what do you get? So this becomes integral of dt by this is t plus 2 whole square, a plus b whole square, I told a square plus 2ab plus b square, t plus 2 whole square, always t plus this b value whatever you are getting, a plus b whole square and a minus b whole square depends on minus or plus here. Next 5 minus 4 is 1. 1 I can write as 1 square, 1 I can write as 1 square. Now this is the form of 1 by x square plus a square, means 1 by a tan inverse x by a. So 1 by 1 tan inverse x by a, tan inverse t plus 2 by 1. So tan plus t plus 2 plus. Now back substituting t. What is t actually? We do t gave plus sin x. So tan inverse of sin x plus 2 plus tan inverse of sin x plus 2 plus c. Coming to this, integral of dx by 6x square minus 5x plus 1. If you simplify, if you can factorize this, then go for partial fractions. If you cannot factorize, then there is another method called completing squares. First of all, you check whether it can be factorized or not. I think it is factorized. 3 2 is 6. 3 plus 3 plus 2, 5. So minus 3 minus 2 minus 5. So what I want to write is integral of dx by splitting the middle term gives me 6x square 3 minus 2, but minus 3 into minus 2 is it minus 6x. So minus 3x minus 2x minus 5x plus 6x square 100% plus 1. So if I take 3 common from these two, this becomes x minus 3 and minus 1 common. So you want to get 6 1 ja plus 6 means minus 3 minus 2, 100% right. So if I take 3 common, 3x common becomes x minus 2 minus 1 common x minus 2. So integral of this is dx by, you will get finally 3x minus 1 into x minus 2, 3x minus 1 into x minus 2. Now we can go for partial fractions of this. If you can factorize, then go for partial fractions. So this is a by 3x minus 1 plus b by x minus 2. A by 3x minus 1 plus b by x minus 2. b by x minus 2. So this side 1 by 3x minus 1 into x minus 2. If you take LCM, so this becomes a into x minus 2 plus b into 3x minus 1. Now 1 is equal to this. Let x equal to 1 by 3. Let x equal to 1 by 3. You will get a value. A into 1 by 3 minus 2. 1 by 3 minus 2. So plus b into 1 by 3 into 3. 1 minus 1 0. So you will get a value as 3 LCM if I take 3 minus 6. 1 minus 6 is minus 5 by 3. So I want to say a equal to minus 3 by 5. A equal to minus 3 by 5. Next, coming to b value. If I substitute x equal to 2, I get simply b. So 1 is equal to, this is 0, 6 minus 1, 5b. So b is equal to 1 by 5. A is equal to minus 3 by 5. So how can I write this is a by, a is how much? I got minus 3 by 5 by 1 by 3x minus 1 plus b by, b is 1 by 5 by x minus 2. Now integrate this. Now integrate that. Direct integration you can do. So minus 3 by 5 anyhow wrote outside. 1 by x integration log mod x. But there is a small problem here. Log mod of 3x minus 1 not x. 1 by x is log mod x. It's not x, it's a linear function. So divide with the derivative I told. So minus 3x derivative is 3. So divide by 3. This 3 gets cancelled. Next, plus 1 by 5 into. This is log mod x minus 2. Derivative of x minus 2 is 1 only. No need to do. Here not x. This is 3x. That's why you should divide with 3. So 3 gets cancelled. Plus c. This is the final result. So if you can factorize, then go for partial fractions. That's what I want to say. Sometimes you cannot factorize. In those cases, you should go for completing square method. You need to go for completing square method. That we will discuss now. Now exercise 6D. If you cannot factorize, then you should go for completing square method. It is a quadratic equation ax square plus bx plus c, which you cannot factorize, then go for completing square method. Even it is factorized, you can go for completing square method. But if you go for factorization, it will be easy. Partial fractions is very easy. That's why that we will do. Now here we will go for completing square method, which you cannot factorize at all. So we will try to sum from the exercise 6D, then you can understand. 1 by cos x dx by sin square x plus 4 sin x plus 5. Sin square x plus 4 sin x plus 5. Exercise 6D, first one and third. Which now, if I take sin x is t, this is not direct form also. Substitution along with the factorization method. So sin x equal to t. Let sin x equal to t. What is the derivative of sin x with respect to x? What is the derivative of sin x? We know that it is cos x. Cos x dx equal to dt. So instead of cos x dx, I can write dt by sin square x is t square plus 4t plus 5. T square plus 4t plus 5. So now, can I factorize this? I can't. Usually I can't. Even if you can go for completing square. Completing square is sanctioned for anything. Even if it is factorized or not factorized. But partial fractions is better suggestion. Now coming to this. If you do not factorize, if you cannot factorize, go for completing square method, which you learned in our 10th class. So, I will tell you a simple method. Completing square is nothing but this should be written in the form of a plus b whole square. This is a square plus 2ab plus b square. Means, I have in place of 2ab, 4t I have. Means, in place of 2t I have 4. So, b is equal to 3. Always take the coefficient of x, make it equal to 2b. Coefficient of x, make it equal to 2b. Then we will get b. Square b square is 4. B square is 4. Squaring b gives you b square. Now, adding and subtracting b square. Always it will be completing square because dt by t square plus 4t plus b square I told 2 square 4 plus 4 I am doing. I should do minus 4. So that value will not change. Plus 5 as this. I am finding 2b as x quotient and I am finding b square. I am adding b square, subtracting b square. So that plus 4 minus 4 doesn't change the given value. So this is a plus b whole square of the a square, t square, plus b square, 2 square, 2ab, 2 into t into 2, 4t. So this is a plus b whole square always. So for completing square, take b and adding b square, subtracting b square, automatically this is a plus b whole square. This is 5 minus 4, 1. So finally what do you get? So this becomes integral of dt by this is t plus 2 whole square a plus b whole square I told a square plus 2ab plus b square b plus 2 whole square. Always b plus this b value whatever you are getting a plus b whole square or a minus b whole square depends on minus or plus here. Next 5 minus 4 is 1. 1 I can write as 1 square. 1 I can write as 1 square. Now this is the form of 1 by x square plus a square. Means 1 by a tan inverse x by a. So 1 by 1 tan inverse x by a. Tan inverse t plus 2 by 1. So tan plus t plus 2 plus. Now back substituting t. What is t actually? We took t gave it as sin x. So tan inverse of sin x plus 2 plus tan inverse of sin x plus 2 plus c.